Okay, so today we are still doing trig, which means in your calculator you should have already checked that if you open a new document you are in degrees, which, oops, you can't see. This one is in degrees. There we go. Alright, so once I know I'm in degrees, I'm going to darken my screen a little bit. Then we can go and look at today's assignment, or today's notes. If I get today's second. Alright, day 10, mixed trig and application. So today we're going to be sometimes finding angles and sometimes finding sides. Remember, to find a side, we want to set up our trig function as a proportion, and then we're going to cross multiply to solve. So for a side, we're going to always think cross multiply. Whereas for an angle, if we want to find an angle, we're going to use the inverse. So it's important to remember when to find using cross multiply and when to find using the inverse. Okay? We are going to learn a couple new terms today. The first one is regular polygon, which we may have touched on earlier in the year. But a regular polygon, when you see that word regular, it means all the sides are exactly the same length, they're all congruent, and all the angles are also congruent. So we've already kind of looked at some in the past. You know what a square is. All the sides are the same, all the angles are 90. That's a regular polygon. An equilateral triangle, all the sides are the same, all the angles are 60. So that is a regular polygon. Okay? Next vocabulary word, every polygon has a thing called an apothem. The apothem is the distance from the center of a regular polygon to the side. So from the center to the side. And since it's distance, we hopefully remember that distance is always a perpendicular measurement. So when it hits that opposite side, it's always going to hit it at a 90-degree angle. That's perpendicular. Okay? And then it also says the apothem will always intersect the midpoint of one of the sides. So when you draw it in, it's going to divide that side into two equal pieces, because it's always going to be the distance, so 90 degrees, and always the midpoint. So it cuts the side into two equal halves. Okay? Alright, so let's look at this regular octagon. It says stop signs are generally regular octagons with a side length of 34 inches. What is the apothem of a typical stop sign? Okay, so we need to figure out how long that piece is. The only thing they've told us is that my side length is 34. Well, if I know the side length is 34, I know when the apothem hits the side, it divides it into two equal pieces. So I know that this side is 17, and this side is also 17. This entire unit is all about right triangles. So if I kind of think about the fact that this whole unit is right triangles, I probably want to make sure I'm working with a right triangle. So what I'm going to do is I'm just going to draw in what would be the hypotenuse of a right triangle that has one side as one leg as 17 and the other leg as an apothem. Okay? In order to apply trig to find a side, I must know one of the acute angles. The only angle I know right here, right now, is the 90 degrees. Okay? There are ways to find both this angle by the corner and this angle at the top. To find this angle down here, we need another formula that we haven't learned yet. So we're going to focus on this one at the top and think about how we can know what that one is. If in a regular polygon, I draw in all the apothems, so from the center to the side, 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 from the center to the side. So I have all my apothems drawn in. And if I draw all what they call the radius of a regular polygon from the center to a corner, because if you draw a circle around a regular polygon, that distance would be the radius of that circle. If I draw in all the radii, every single time you're going to be constructing congruent triangles. I know they're going to be congruent triangles because they're all going to have a 17 here. They're all going to have a 90-degree angle here, and they're all going to have the same apothem. So by side, angle, side, I know all of these triangles are exactly the same. So if you think about every side of this octagon, we turned into 2 triangles. So each of the 8 sides got turned into 2 triangles. How many total triangles did I make? I made 16 congruent triangles. If I put all of those triangles together all at one point right here, like how they are, when I put them all together at this angle up here, how many degrees is all the way around that center point? 360. So if I want to find out what one of those angles is, how can I figure out what just one of those angles is? Divide. I'm going to take 360 and I'm going to divide it by 16. So I had 8 sides, but because I divided each side into 2 triangles, I'm really dividing by 16. So if I had a hexagon with 6 sides, I would be dividing by 12, right? Because we would divide by 2 triangles per side. Can we put our phones away, please? Thank you. All right, so what is 360 divided by 16? 22.5. So that's going to be this angle right here. It's hard for me to fit it in there, so a lot of times what I'll do when the picture isn't big enough for me is I'll just resketch the triangle that I'm working with a little bit bigger. So I want to find this apothem. I know this side is 17, and I know this angle is 22.5. Well, at this point, we're ready for trig, right? I can put my smiley face at the acute angle that I know. So it's going to be the 22.5. And then from there, I can label what's my hypotenuse? The unlabeled side. Which one's the adjacent? The A, the apothem, which is kind of convenient if you use that angle up there. If later when we learn how to find this angle down here, then that becomes the opposite, and then it gets confusing because your A is your opposite and not your adjacent, and it's weird. So this is convenience that the angle we found has A, which is the apothem, also being the adjacent. And then the 17 is my opposite. When I look at SOHCAHTOA, I'll figure out which trig function I want to use. What 2 sides am I working with?
Opposite and adjacent.
The opposite and adjacent. So which trig function am I going to work with? The tangent. Am I going to cross multiply or use the inverse? Cross multiply, because I'm looking for a side, right? I'm looking for the side length of the triangle. So I'm going to be cross multiplying, which means I set it up as a proportion. So the tangent of what goes right next to tangent? The angle, 22.5, equals the ratio opposite over adjacent, so 17 over the adjacent. Put this over 1 to make it a proportion, and then cross multiply. The apothem times the tangent of 22.5 equals 17 times 1. And again, you can skip that step if you remember, oh, my variable's in the denominator, I'm going to divide the 17 by the 22.5. In my notes, I don't like to skip that step just because I don't want, if I'm looking back to try to study, I want to know why I divided. Tangent of 22.5. So then my apothem in my calculator, I'm just going to do 17 divided by the tangent of 22.5. It's a side length, so I'm going to round it to 3 places. 41.042. And since we know the original side length was 34 inches, that means these are also inches. So the apothem of this stop sign is 41.2 inches. The next question says, okay, use the apothem to find the total distance across the stop sign. So I know going towards the apothem, that far is 41.042. If I do that much again, how do I figure out what that total length is? Yeah, you just multiply by 2. So it's just going to be the distance across is going to be 2 times the 41.042, which will be 82.084. And these are, again, still inches. That seems like a really big stop sign.
It's 6 feet.
Yeah. I have to Google that later and see if that's really how big stop signs are. But that seems like a really big stop sign. Way taller than I am. By like 20 inches. Okay, next. Number 2, a submarine at the surface of the ocean makes an emergency dive. Its path makes an angle of 21 degrees with the surface of the water. How many meters must the submarine travel along its downward path to reach a depth of 1,000 meters? What should I do first? Yeah, let's draw a picture. Your pictures can be as simple or as elaborate as you like. However fancy you like to get with your drawings. Okay, so we have a submarine. Get it? We all live in a yellow submarine. No? Okay. My submarine is at the surface of the ocean. Its path makes an angle of 21 degrees with the water. So that means coming down from the water, the path it's going to make as it dives, because they don't sink, right? They dive down, is going to be 21 degrees. Path and water. Okay. How many meters must the submarine travel along its downward path? So when it's down here, it's reached is a depth of 1,000 meters. So that means we are now 1,000 meters below the surface of the water. I felt like we needed a fish. It's a really big fish compared to the submarine, but that's okay. I felt like we needed it. All right, so let us solve this problem. Okay, first of all, what angle am I standing at? The 21 degrees. What is my hypotenuse? The path. What is my adjacent? The water. Meaning the depth is my opposite. So, toa. Now, we need to make sure we read, because since we had to draw our own picture, we have to make sure the X goes in the right spot. How many meters must the submarine travel along its downward path? So where am I putting my X at? The path. This is what I'm trying to find here. So that means I need to find the path. That's the hypotenuse. And I know the opposite is 1,000. Which trig function do I want to use? Sine. sine is the trig function we're going to use. Cross multiply or inverse? Cross multiply because I'm looking for a side. My angle is 21 equals the ratio opposite over hypotenuse. My opposite is 1,000. My hypotenuse is x. So again, in this problem, when I put this over 1 and I cross multiply, I'm going to have to divide again, which you can skip writing this step down. I like to, again, put it in my notes so I don't forget how I got to the next step and why I divided. We're going to divide so that we get the x all by itself. So x equals 1,000 divided by the sine of 21 to 3 decimal places. Oh, it doesn't give us 3 decimal places, so we're just going to give what it gives. 2,790.43. What are my units? Meters. All right, let's keep going. All right, I did tell you we're going to learn a couple of expressions today. We did regular polygon, we did apothem. Now we're going to talk about angles of elevation and angles of depression. So an angle of elevation is the angle that a person's line of sight, and your line of sight is always horizontal, okay? It is the line of sight and then how much from that horizontal out of your eyeballs, how much you have to look up, okay? So angle of elevation is how much up from a horizontal line. And then angle of depression is how much you have to look down from a horizontal line. Okay, so angle of depression, looking down, angle of elevation, looking up. It's kind of weird because depression, we usually see it up high in a picture, and elevation, we see it down low in a picture, which seems counterintuitive, but because you need to start low to look up to elevate, right? You need to start up to look down to depress. Okay? When an angle of elevation and an angle of depression are on the same transversal, so when this line connects an angle of depression and an angle of elevation, if they're on the same transversal between two parallel lines, which they'll always be between parallel lines because they're always compared to a horizontal, they can be classified as, what type of angles are those? No? Alternate interior angles. Alternate interior angles. Okay. So if we have two alternate interior angles and two parallel horizontal lines, what do we know is true about alternate interior angles when we have parallel lines? They are congruent. This is important because a lot of times they'll give you the angle that you don't need. So they might give you this angle of depression, but then when you're drawing your picture, your triangle's down here. So it's important to know that those will be the same. Or they might ask you the angle of depression and then this one's inside your triangle, so you find this one knowing it's the same as that one. Or they'll give you this one and you need to find that one. So it's important to know that they are the same. Okay? Let's look at example 1. A person on a zip line travels a horizontal distance of 109 meters on a 120 meter zip line. Okay, so they are on a zip line, which means they started up off the ground, they climbed a ladder or a tree or something to end up above the ground. And then there's a cable that they zip down till they reach the ground. And so they're harnessed in. That's my little guy in the zip line. Again, never took art. And I'm going to pretend it's in the spring, so the ground is grass, so it's green. Okay. We traveled a horizontal distance of 109 meters. Where does the 109 go? On the bottom, right? That's the horizontal distance. It's a 120 meter zip line. Where does the 120 go? Where the guy is, right? Where he's zip lining. What is the angle of depression of the zip line? So the angle of depression of the zip line is going to be, if we were looking straight out before we started going, how much we'd be looking down when we look down at the zip line. This is what we're trying to find, but that's not inside my triangle. But because we know the angle of depression and the angle of elevation at the other end of the zip line are the same, we can get that x to be inside the triangle where we want it. Okay? All right, so now let's solve this problem. We have two x's, but when we put our smiley face, we want to put it by this x that's inside the triangle. Where's my hypotenuse? 120. Okay. And then where is my adjacent? 109. And then the height that we start off the ground, that is my opposite. Okay. And so that's where we get our 90 degree from. We think about that as the height. So if this question asks what's the height he starts off the ground, right, then I would use Pythagorean theorem to find his height at his starting point. All right, so when I look at SOHCAHTOA, which trig functions am I going to want to use? Cosine. Cosine says adjacent. Yes, I have the adjacent. And hypotenuse. Yes, I have the hypotenuse. So I'm going to use cosine. Am I going to cross multiply or inverse? Inverse, because this time I'm looking for an angle. When we're looking for an angle, that's when we're going to inverse. So I'm going to put the little -1, and instead of putting the angle next to the cosine, I'm going to put the ratio adjacent over hypotenuse. So 109 over 120. That's going to give me the value for x. And we're going to round to the nearest degree just like we did yesterday. We'll always do the nearest degree for angles, unless otherwise indicated. So cosine inverse of 109 divided by 120 is how many degrees? 25 degrees. Questions? Okay. Next. From the top of a 575-foot bluff, a rescue scout looks down upon a hot air balloon accident. The angle of depression is 7 degrees. Draw a sketch and find how far the accident is from the rescue team at the base of the bluff. Okay. So, do we know what a bluff is? It's like a cliff. Up high, like on a cliff. So, we are 575 feet above the ground on a bluff. Up there is the ranger, and I like to imagine that he's like laying on his tummy, like looking out over the edge with his little binoculars. So I always draw him lying down. It's just what I do. And he's got his little binoculars, he's got his little ranger hat on. There he is. You know. Alright, then he's looking down upon a hot air balloon accident. So somewhere over here is a hot air balloon accident. So you need the basket, and you need the strings that hold the balloon. And they're going to go kind of like this because the balloon's on the ground because it's an accident. Balloons are usually colorful, so let's make the balloon blue. Maybe it also had some green. Oh, that blue and that green are real close together. Let's throw some pink in there. And I mean, somebody had to be in there, and so they're falling out. Help me. Somebody might have actually falling out. I don't know. Help me. Poor guy. And let's see, these things are made with propane. So probably if it crashed, it's on fire. Because, I mean, why not? Yikes. Okay. Was it unnecessary? Oh, sorry. Okay, so we really got to get this rescue team to this accident because it's dire over here. Okay. The angle of depression is 7 degrees. So when he looks down towards the accident, the angle of depression, so you can look at the accident, if he were to look straight out at no degrees, he'd have to tilt his head down 7 degrees, which we know is also the angle of elevation. Draw a sketch and find how far the accident is from the rescue team at the base of the bluff. So at the bottom of the bluff is the rescue team. Okay, they're on their way. All right, so where am I going to put my X? I didn't put an X anywhere in this picture. On the bottom, right? We want to know how far is it from the rescue team to these poor people in their accident. Okay? All right, so now I need to put my smiley face. Where's my smiley face going to go? By the balloon. I mean, maybe it should be a frowny face instead of a smiley face this time because this is not a happy situation. It would be ironic to have a happy face there. Where's my hypotenuse? The unlabeled side. Which one's adjacent? X. Which means 575 is my opposite. We're looking at SOH, CA, TOA. Which two sides am I working with? Opposite and adjacent. So which trig function? Am I going to inverse or cross multiply? Cross multiply. So I set it up like regular. Tangent of 75, or sorry, 7 equals, and then what goes on top? 575 over X. I am going to need to cross multiply, so I put the left side over 1 and get X times the tangent of 7 equals 575. Am I multiplying or dividing? Dividing, because I don't have X equals, I have X times. So I need to move this tangent of 7 over. So X is going to equal the, 575, I have to put that in first. 575 divided by the tangent of 7, which gives me 70. Did I do that right?
Yeah, no.
You times it.
Oh, I times it. I was like, that seems like a really small number, 70 feet. You could just be like, you can't see them? You don't need a rescue scout for 70 feet. 575 divided by the tangent. That seems better. 4,683, which is just under a mile. So it's about a mile away. So, feet, yes. It takes 5,280 feet to make a mile, so you just tell them if you've gone a mile, you've gone too far, but just drive towards the smoke, because, yeah. Questions on 2? All right, one more. Suppose the apothem of a regular pentagon is 4.12915 centimeters. What is the perimeter of the pentagon? Okay, So the first thing I'm going to have to do is I'm going to have a right triangle, right? That's the first thing we need to do. So I know my apothem is going to hit at a right angle. And then I can draw in the radius. Oh, sorry. So then we can draw in the radius. And we know the apothem hits the side and does what to the side? Divides it exactly in half, right? So if I can find this little piece here, these two will be the same, and then I'll know how long my sides are to find my perimeter. Okay? So the first thing I need is I need an acute angle. So we need to figure out what this angle is in here. If I were to draw in all my radii and all my apothems, do you know how many triangles we'd end up with? We ended up with 16 when we had an octagon, but now we have a pentagon, 10, right? Because you're going to divide each side into 2 triangles. So that's going to give you 10. They would be, if I used a ruler and made them really nice, they would all be congruent triangles because they'd all have the same side length, half of a side. They'd all have the same apothem, and they'd all have the 90-degree angle. So by side angle side, they'd all be congruent to each other. Okay? So this time I'm going to take that 360 to find that inside angle, and I'm not going to divide by 16. I'm going to divide by, there's 10 angles, so by 10. Which is going to give me 36. So that's this angle in here. If you'd like, you can I usually do, just because I like them to be a little bit bigger and not have all this stuff going on. 4.12915, and usually if they give me that many numbers, they want me to use all of them for a reason. And 36. Where does my smiley face go? 36. Which one's the hypotenuse? The unlabeled. Which one's adjacent? The 4.12915, meaning the x is the opposite. We're going to look at SOHCAHTOA. Which 2 sides are we working with? Adjacent and opposite. So which trig function do we want to use? Tangent. Were we going to use the inverse tangent or regular tangent? Regular. We're looking for a side. So that means I put the angle next to the tangent, and then I put my ratio. Opposite over adjacent, so x over 4.12915. Am I going to multiply or divide on this one? Yeah, this is going to be the first time today we get to multiply, because I end up with x times 1, so x is all by itself on that side of the equals. And then 4.12915 times the tangent of 36. So 4.12915 times the tangent of 36 is 3. That's not my answer though, right? That's just x, which means this piece here is also 3, which means a whole side is 6. So what is the perimeter? 30, because each side is 6, there's 5 sides, so 30 centimeters is my, oops, y'all couldn't see that, is my perimeter. Questions? All right, your assignment is available to you in Schoology.